Hello everyone. In this video we're going to be finding the inverse of a very interesting function. We have f of x equals x to the power ln x, and we're going to be finding f inverse of x, which is the function that does quite the opposite of what f does. So inverse of a function is basically that doesn't exist for all functions. First of all, a function needs to be one-to-one, because if you have the same output for two different inputs, then obviously inverting this would violate the function being a function, or the functionness, or well-definedness property. So that's why we need to make sure that this is actually a good function. But anyways, how do you find the inverse of a function in general? Let me go ahead and show you how to find the inverse of a function, picking an easy example, and then we're going to apply it to our situation, because not all functions are created equal. You have to treat them differently sometimes. But let's think of another, like a really quick simple example. What if you have something like f of x equals 2x plus 1? You've probably seen this before. It is a linear function, right? Now, to find the inverse of a function, we kind of need to think about, okay, x takes, or f takes x to y. What takes y to x? That's what we need to think about. Make sense? So here's how we're going to proceed. The first step is replace f of x with y. By the way, you don't have to do it this way, but I like to do it this way. And then I usually switch sides so that x is on the left-hand side, the expression that contains x, obviously. And then I'm going to proceed with solving for x. Our goal is to get x by itself, and I'm going to tell you why that's the case. But let's go ahead and do it first. Subtract 1 from both sides, and then divide both sides by 2. That'll give you x in terms of y. That's exactly what it is. Because if you think about it, x takes, f takes x to y, and then we need something that takes y and brings us back to x. So this is exactly what it is. So in other words, the rule says, okay, take a value x, double it, and add 1. Let's take 5, for example. What is f of 5, right? It's 11. And f inverse is going to take the output 11 and brings it back to 5. How is that? How does that do it? Well, you just have to invert the process. Subtract 1, which is 10, divide by 2, and you'll get 5. That's the whole idea. Of course, this is just a particular example, but you can always generalize it. You can even pick a general example like f of x equals ax plus b and do the exact same thing, but that's the same idea, okay? So let's go ahead and see how we can apply this rule to a function like this. But before that, I want to show you something else. Now, not all functions are inverted easily, right? That's one thing that we need to talk about. For example, what if we had something like f of x equals x squared plus x minus ln x? You wouldn't be able to do it. Why? Because if the answer is buried in y. Because if you set this equal to y and then try to solve for x, you wouldn't be able to. The problem is this is such a non-standard equation. It's not a polynomial. It's not logarithmic. It's a mixture of different things. So you can't really solve for x. That's why you can't find an explicit way to function. Same thing even goes for Lambert's W function. Remember, x times e to the x, if you invert it, it'll be Lambert's W function. And I use that a lot in my videos, right? But why is it not possible? Because when you set this equal to y, how are you going to solve for x? You can't. Unless you use a special type of notation that says, okay, let's define a function w such that if it takes the input x e to the x, it'll give us the output of x. And this is called the inverse of x e to the x because it just inverts it. Make sense? Great. So not all functions are easily invertible or inverted. Of course, invertible meaning that it's one-to-one, so on and so forth. And of course, it also has to be not just one-to-one, it needs to be a bijection. Okay? What if a function is not one-to-one? Then you can talk about several inverses. And how we can tell is a very simple example. F of x equals x squared has two inverses because if you think about it, it's not one-to-one. And you can determine that it's not by looking at the horizontal line test. If the horizontal line test gives you more than one intersection point, then this function is not one-to-one. So you kind of need to split it up into two pieces. Maybe just consider x is greater than 0 and take inverse for this branch. Okay, great. So you can basically go ahead and proceed with so many examples just to get the basic idea. If you're new to inverting functions, then this will be helpful because the function we're about to deal with is not an easy one. It's actually quite complicated. But let's go ahead and get to it. So now f of x equals x to the power ln x, right? So you might be thinking, okay, easy. You just talked about it, right? Why you have to give us so much background? Well, set it equal to y, and then I wish you good luck finding x from this equation, right? So you kind of need to solve for x. But solving for x is not easy because this is like a super duper interesting exponential, logarithmic, exponential, whatever type of function. It's a very non-standard function. So how do you solve for x? And the answer is you have to bring down the exponent because the exponent is a variable. For example, if you had x cubed equals y, solving for x would be super duper easy. You would just cube root both sides and boom, you're done. That's it, right? But in this case, you don't have that luxury because the exponent is a variable or a function. So let's bring it down. How do you do that? Well, it's kind of easy. You have to use properties of logarithms. In other words, ln both sides. And what that does is actually kind of like a miracle because it's just going to bring down ln x to the front, and ln x, of course, will be multiplied by the other ln x, and that'll give us ln y. How nice. But what is ln x multiplied by itself, right? Well, it is just ln x quantity squared, right? So let's go ahead and write it as follows. Ln x quantity squared equals ln y. Don't lose sight of the fact that you need to solve for x, okay? That should be your main focus. But guess what? We have two solutions, which means this function isn't one-to-one, and you could have checked that, or just graph it in Desmos, whatever tool you'd like to use. But this shows us that there's going to be two solutions. Why? Because there are two numbers whose square equals ln y, right? Okay, as long as ln y is positive, y has to be greater than 1, so on and so forth. But those are different things. We don't need to worry about it much. But from here, we can get ln x equals the square root of ln y, or ln x equals the opposite of the square root of ln y. Now, which one should we use? Well, you should find both inverses, but guess what? I'm going to just proceed with one of them, and you'll do the other one. That's going to be your homework, okay? That's for you to find out, and I think that'll be a good exercise. Now, let me show you this one. The other one is very, very similar. So, remember, our goal is to solve for x. Did we? No, because we still have ln x. We don't have x by itself, but it can be easily done. Think about it. X is e to the power ln x. All you have to do is e to the power both sides, and ta-da, you're done, right? The magic touch or mathematical touch. Okay, great. So this is x. So what? Okay, I forgot to tell you. Now, when you have something like y equals f of x, and then you want to find x in terms of y, which gives you f inverse of y. So when you actually solve for x in f of x, or f of x equals y, when you solve for x, you're finding f inverse in terms of y though. But you want it in terms of x, don't you? You're looking for something like this, f inverse of x. So all you have to do is now change the y to x. But don't worry, it's not the same one. But let's do this. Replace x with f inverse of y, which will kind of help you in the process. Otherwise, you'll be confused. Sometimes people say, like, what do you switch? What are you doing, right? But now, forget about everything else before this. Now, focus on this. And remember, our goal is to find f inverse of x. All you have to do is replace y with x, and you're done. And that'll give you e to the power square root of ln x. And guess what? You can check this with numerical values or just plug it in, because f composition f inverse should give you the identity function, which should give you x when you input x. Okay, so this is one of the inverses. You got to find the other one. That's your homework. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.